Alright guys, welcome back to the another video. In this video, I'm going to show you how to detect the flooded area using deep flooding approach. So if you want to know how I did it, please watch this video till the end. Let's get started. All right, so before starting the tutorial, so I want to show you again the methodology. So we have the input data set and we do the pre-processing and we wrote the custom data generator function, and after that we are going to like apply the attention unit, and then we measure accuracy, precision, recall, and F1 score, and then we predict the plots segmentation. And for the custom data generator inside, we already uh, wrote the function to get the image in max augmentation and then normalization, and also try to solve the memory issue. And here in the custom matrix actually, so we are going to calculate the accuracy, precision, recall, F1 score, and intersection over union. And this is the like confusion matrix. That means if our like actual value if our actual value and then the predicted value are same, then we get either true positive or true negative. And if our prediction is wrong, then we will get FP and FN. And this is called the confusion matrix, and based on this confusion matrix we have accuracy, precision, recall, and F1 score formula over here. So these are the like quite popular matrices in the image segmentation tags to evaluate the model. And yeah, so I already talked about attention unit. So why we need attention unit? uh, so let's get start to the code. And here in the code section as well, so before starting the session, so you need to manage your you need to like change your runtime type and change it to T4 GPU. And also after that, simply like connect your driver Google Drive by clicking on this link, and after that you will see the another folder called drive, and here it is. And then I already uploaded the dataset inside flood folder. So the dataset I got from flood area segmentation. There are 290 image in max pairs, and based on this we are going to train our model. And also if I show you in my Google Drive, so I already uploaded my image in max pair. All right, so after that, simply you need to like run these functions. So I think in my previous video I already explained about custom data generator. If you haven't watched that video, uh, please feel free to check the playlist on flood segmentation in the description. And yeah, so from this custom model we are simply like checking whether our train batch and test batch, I mean the data set, image and max pair are right or wrong. So looks like it's correctly like assigned and correctly pre-process our data set. So yeah, and then after that in the previous video I also showed you how to like get your unit attention unit function. So yeah, so this is the attention unit function, and this is the model. And then if you summarize the model, you will see something like this. You have 12 million parameters. All right, so after that you need to split your train and test dataset. So for that you need to like import the train test split function from sklearn.model selection. After that you have train image, train max, and test max, and this is based on image and max pair. And then I just assign the random state to 42. And now I have like test size of 20% of data, and then train size of I think 80% of data. And then if you try lane train img and then lane test img, then you'll see the train and test image shape, I mean the length. So the we have 232 images for the training, and then 58 images for the evaluating or testing the model. And after that we need to like, these are simply just the name of those image and max pair. So if I show you up here, so this image and max are the just the image and max pair, just the name of those images. And we need to fit that images into custom data generator function, so that we can use that in the model training process. So in the custom data generator we pass train image and train max, and then test image and test max to train to evaluate our train dataset and test dataset, uh, and then train our model. And if you try the train dataset and then the test dataset length, now this time it will be like 29, and then this is 8. The reason for this length is like, as I said before, so the custom data generator function return the batch size. So we have batch size of 8. That means if you divide 232 divide 8, then you will get 29, right? So there are 29 batch, and then similarly 59 divided by 8, so that means 7.3. So in the last batch we don't have the 8 images in max pair, that's why it's 7.3. So that means 8. That's why our length is 29 and 8. It's not actually the length of all the images, but actually it's the length of like number of batches. All right, so for the like custom matrices, so I'm going to copy and paste the code from my previous notebook. So as I said before, we are going to like calculate the precision, recall, and F1 score, and also the DSC, which is dice score, dice coefficient, and then the dice loss. Also, instead of like binary cross entropy function, you can like apply the dice loss function in the like loss function, and then train the model. So these are just the formula. Based on that formula what I showed here, so the I'm simply implementing those in keras. So that's all. Now our model is ready, so I want to train it using some of the callbacks function. So here for the callback function, so I'm simply checking a check pointer callback function, and then oddly stopping callback functions. So both are from the TensorFlow keras. And the thing about like check pointer is like, whenever we train the model, and then it will try to save only the best weights based on the Bhal F1, which is the F1 score based on validation dataset. And the mode, make sure to like write mode equal to max, so that you will get the like best model based on F1 metrics. And if you are going to like use the monitor is loss function, then you simply write it as val loss, and then mode equal to minimum. And this oddly stopping callback function is for like, if your model start overfitting the dataset, then you will like wait till the 5 epochs, during which if you see the F1 score is not not updated, I mean not getting better, then you'll simply terminate the model. That's why we have oddly stopping function. And yeah, and then when training the model, so I'm passing my training data set is the custom data generator of class, and then if was of 50, and then var was 1, And then for the validation dataset, simply since the dataset I have really less amount of data, that's why I'm passing just the test dataset. But I highly recommend you to do the validation split if you have enough dataset, and then the callback function. And then if you run this function, so it will also, like, at the end it will save the model as flood save.h5. I'm not going to run this function over here, but instead I want to show you some of the result from my model. So here I train the model, and then you can clearly see that my val f1m is improved from infinite to 0.52, and after that it's improving in few epochs, but in few epochs it did not improve. For example, in 6 and 7 epochs it did not improve. And yeah, so after that, so we get like where is the, yeah, here. So in the epoch 25 we get like f1 score on the validation dataset is 0.83. And after that we our model did not improve, and then it stopped at 30 epochs. And this is the like graph of training and testing dataset. You can see that our loss is like increased significantly during last epoch. So that's why we are simply ignoring this. And in the f1 score also, you can see that f1 score dropped significantly during the, I think, last epoch. And we are just taking the highest f1 score model, which might be from here or here. Okay, so that's all. So after that I have this function to load my model. So maybe I can jump back to the previous section, and then okay, so load the model. But if you try to, like, from keras.model you can import load model, but if you try to like load the model without doing anything, so you will end up with this error. Okay, let me show you. Okay, this is the error, like unknown matrix function f1m, because this is the custom matrix that we wrote in above section, and that's why it's throwing an error. So I need to pass this custom object equal to custom object. And make sure, since I already trained this model, and then my weight, best weight is available here in the my Google Drive. That's why I'm doing simply loading my model from like my best weight. But if you don't have any like sorry, I need to remove this. Okay, if you haven't trained your model, then you need to like train your model and then load your best weight using load model function like this. Okay, and whatever new custom objects you wrote during training the model, then you need to like assign those objects like this: f1m, precision m, recall m, dsc, right? And then if you test it with the loss function, custom loss function, then you can also you need to define the loss function as well. All right, so after that let's try see the accuracy. So for the accuracy, so we are using model.evaluate function, and it will like return the loss and accuracy are the default one. But since we have the f1 score, precision, recall, and dsc, these functions, I mean these custom metrics, then it will return these as well. So let's see how much accuracy we get. All right, so here our loss value is 0.28 and our accuracy is 87.82%, which is quite good. And our f1 score is 0.84 almost. I think that's also really nice. And precision 85, recall 83, and dsc dice score is 74. That's really amazing. And actually, in order to like test the model with the custom dataset, you can like download the flooding area, and then you can like download the random images from like Google, and then try to like predict on those models. So maybe I'll save few images and show you how it works. All right, so now I have downloaded the random images from Google. So these are the like three images: flood 1, flood 2, and flood 3. I downloaded from Google, so now I'm going to upload it to the Google Colab and see how it works. Okay, so here drag and drop your images, and flood 1, flood 2, and flood 3. So I have these three images, and this is just the warning, so you can ignore that. And now so for the prediction, so I need to like use the glob function, glob.glob, and then I need to select like .jpg file from this folder. And then now I'm converting those into the 512 by 512 by 3 size, and then normalize my image over here, and then I simply add that into my array. And yeah, so okay, so after that, I can like predict my image with the predict equal to model dot predict, and then I can pass my test image, and then I can say that if the threshold value is 0.5, if the value is greater than 0.5, then write it as 1, otherwise 0. That means if it's the value is 0. Greater than 0.5, then it's flooded region, otherwise it's not. And then you can check the predicted shape as well, so it might take few seconds. All right, so it looks like we have three images of 512 by 512 by 1 shape. And now in order to like visualize those side by side, I have like drawn three rows and two columns, and I am going to like plot those images in max, and then you can see that it looks a little bit like nicer. So we can clearly see that this is the area where we have like water, but it is not the perfect model, since it is just the like predicted on only 290 images, right? That's why it's not the perfect model. But if you can like see the accuracy, it start like detecting the water bodies pretty nicely. And you can see that this feature is excluded over here. And then yeah, most of the like water area is represented by the yellow color. And here also, yeah, similar story. But of course, model might get confused with the uh, few like few of the images. Like for these buildings, it detect as a water body, but it's not the water and not the flooded region, right? So it really depend on the number of data set you have, and then the accuracy of your data set that you produce. So with only 290 set of data, we downloaded the random images from Google, and then it's start predicting nicely. So that's really good. I also want to show you few different other images that I tested before. So okay, so here in this image, it did pretty good job. It exclude the tree over here and then these buildings. So it has really nice prediction on the flooded region. And in the second image as well, you can clearly see that this region it detect as the flooded region. And then there might be some error over here because these are like very noisy. And of course it really depend on the input training data set, right? And also in this image, it has really good job, it did really good job predicting the flooded region. So yeah. that's all about like flawed segmentation using deep learning. So in this way you can simply build your unit, I mean any deep learning model, to test your like flooded area using like any of the imagery available on the internet, or using like drone imagery. And if you want to try more, you can use the sentinel dataset for the flood, which is over here in the Kaggle. So it's in the kaggle.com dataset in uh, Biraj Kadam slash Sent12 Flood. And then this dataset is for like Sentinel-1 to imagery and the flood mask. And yeah, so if you tried this model, let me know in the comment section how much accuracy you get and how is your model training goes on. So yeah, that's all about like flood segmentation, flood mapping using deep learning. I hope you enjoyed this video. If you enjoyed this, hit the like button and subscribe to my channel. Thank you for watching.